So good morning. Okay, good morning one and all. This is error control coding 20 CS 23, the second semester MTech subject. So let us go through the syllabus and then we'll see where the syllabus is within each of in the books there. So the first part is information theory and the introduction to algebra. So you can see that this is from chapter 5 of text 1 and chapter 2 of text 2. Then later as we go down, linear block codes, chapter 3 of text 2, cyclic codes, chapter 4 of text 2, then BCH is chapter 6 within the chapter 6 of text 2, and then the 7.2 and 7.3 of the text 2, and majority logic decodable codes is 8.1 to 8.1 and 8.4 of the text 2. So then you have the convolution code or convolutional code. Sometimes it is told that way also, which is 11.1 to 12.1, 13.1 of the text 2. Okay, so let us see what are the text 1 and the text 2. In between, he has put some exercises also. So if you see here, it is Digital Communication Systems by Simon Hakins is the book 1, and Error Control Coding, Shulin and Daniel G. Costello is the book 2. So going back to the what you call syllabus, our syllabus itself, right? So only the half a module is your what you call book 1. The rest of the thing is book 2. So we have the book 1 over here, which is there, and the chapter 5 is what we need to see. So let us see the chapter 5. Which part of the chapter 5 we have? So I'll just expand this over here. So in this, if you just go back to your syllabus here, I think, is it visible or shall I make it much bigger? So here, you have introduction, entropy, source coding theorem, discrete memoryless channel, mutual information, channel capacity, channel capacity, and then channel coding theorem. Okay, these are the parts which are there. So if you go back here, it is 5.1, 5.2, 5.3. 5.4 is not there in the syllabus. So you can just write down, might be somewhere 5.1, 5.2, 5.3, then 5.5 directly, because we have after that discrete memoryless channel. Then mutual information is also there, that is 5.6. So no 5.4, 5.5, 5.6, 5.7 and 5.8. 5.9 is also not there. So it is the whole of the chapter 5 except 5.4 and 5.9. Okay, whole of the chapter 5 except 5.4 and 5.9, that is half a unit of the whole subject. Okay, so then we have the introduction to algebra as the next part, where we have groups, fields, binary fields and all that from the error control coding book. So let us see the chapter 2 of the book over here. So chapter 2 is over here. groups, fields, binary field arithmetic, construction of Gallus field, construction of Gallus field. That means 2.1. Sorry, 2.1, 2.2, 2.3, 2.4. I think all those things are there. Groups field, binary, construction of and its properties, but only statements of the theorems without proof. Then computation using the Gallus field GF arithmetic. That is the I think 2. Computation basic properties also there. I think Gallus field and properties he has written, right, and its properties. So even that is also there. So then computation using the Gallus fields arithmetic. Vector spaces is also there. I think vector spaces and matrices also there. So to say, if we see over here, then I think the whole of the what you call chapter 2 is there from 2.1 to 2.8, but no derivations within the what you call construction of Gallus fields, as well as in the 2.4 and 2.5, only statements, no derivations. That is what is written there in the syllabus, right? Only statements of the theorem without the proof is the part which corresponds to the 4 and 5, 2.4 and 5, right? That is half the module, half the module. Then going to the next topic over here. Module 2 is linear block codes, chapter 3, text 2. I think most probably more, whole of the what you call, chapter 3 is there from the book 2, text 2. So generator, parity, check matrices, encoding circuits. Where is it? Block of codes. This looks totally different. Generator, parity check, encoding circuits, syndrome and error detection. I don't know, inside syndrome and error. Okay, introduction to linear block codes might be the one which will correspond to generator and parity check matrices and encoding circuits. Then you have the syndrome and error detection. We'll see whether in the first edition it matches. Then minimum distance of codes, minimum distance considerations is there. Error detecting and error correcting capabilities. Error correcting capabilities 3.4, 3.2, 3.3, 3.4, 3.1 might include both the first and second part there. Then you have standard arrays, yes, syndrome, single parity checks and repetition code, single parity check and repetition code, self dual codes 3.7 also. 3.7 also, self dual codes, Hamming codes, Reed Muller codes. This doesn't seem to be here, might be in the so to say here it is there, right? Reed Muller code, Hamming code. So it is chapter 3 as well as chapter 4 in this. So might be, let me try to open the first edition, because this is the second edition, that's why it is looking like that, might be. So let us try to see whether it is corresponding to the first edition. Okay. Okay. No, it is like that only here also, almost. Not much difference. Might be it is matching with this. I don't know. Okay. These things are same. Probability of undetected error is not there, I think, in this. Okay. Hamming code, Reed Muller code, product code, interleaved code. I think most probably he has taken from the chapter 4 only. Hamming code, Reed-Muller code. Product code, interleaved code. Yes, it's matching with the second edition only, right? Interleaved code is also there. Yes. So rather it should have been chapter 3 and 4 of the book over here. Okay, let it be, no problem. Then you have the cyclic code. So there's a lot of confusion, might be what you call cyclic codes. We have cyclic codes in this new edition is, if we talk about new edition, it is in the chapter 5. But in the old edition, it is the chapter 4. Okay. So, but introduction, generator and parity check. Here he has written a little different ways. Okay, description of cyclic code is what he has written here. Same. Okay, naming is different, so nothing to worry. Might be here he has given introduction. Here he has given what you call description of cyclic codes. So then generator is the second part. Encoding of cyclic codes is there. Encoding is there. Syndrome computing and error detection is there. Syndrome, yes, same thing. Then decoding of cyclic codes and cyclic Hamming codes is what we have here. Cyclic codes Hamming, okay, error trapping, decoding is there. Then shortened cycle codes is there. Error trapping is there. Decoding of cyclic codes, decoding is there, error trapping is there, cyclic Hamming is there. Improved error detection, goals, all these things are not there. Only shortened cyclic codes is there. Okay. So as it looks here, 5.8, 5.9, 5.11, 5.12, these things are not there. Okay. 5.8, 5.9, 5.11, 5.12 is not there. Okay, till 5.7 it is same, but then it goes to 5.10. Shortened cyclic codes, other things are not there, right? So that is where we stand as far as the module 3 is concerned. Okay, in the new edition only. So we'll go with the new edition. Will not go with the first edition. In the syllabus, has he mentioned that edition? Second edition only what he has mentioned. Fine, okay. But again, chapter might be different. Fine. So he has got a lot of confused, it looks like. Okay. So that is the cyclic codes module 3. Then module 4 is the 6.1, 6.2, and 6.7. He has made it very clear over here in the text too. 6.1, 6.2, and 6.7 for module 4. So BCH code. Yes, BCH code is chapter 6, 6.1, 6.2, and 6.7. Yes, 6.1, 6.2, and 6.7, binary primitive BCH code, decoding procedures, implementation of Galois field arithmetic. Then you have the primitive BCH code or GFQs. Okay, 6.1, 6.2, and 6.7. The term primitive, I don't know where it is. So there he has not written which part of it belongs to that. We will have to check where this is. Okay, primitive BCH codes for the Galois fields is what is mentioned over here. Might be it is there somewhere. Is it there? Okay, here.
It is in 7.2, sir.
Yes, it is in 7.2. Primitive BCH codes for GFQ. Right? Even though it is not written there, might be it is written later, right? He has written 7.2 and 7.3 here, right? So he should have merged these two primitive BCH codes and read Solomon codes is 7.2 and 7.3 in the book. Okay, so yes, 7.32 and 7.3 in the book. Fine. Then we have the what you call from the 8th chapter, majority logic decodable codes 8.1 and 8.4. Okay, so that is chapter 8. 8.1 is one-step majority logic decoding, multiple step majority logic decoding. Is it same over here? Yes, one step and multiple step. 8.1 and 8.4 from the book. That is matching. So, okay, everything looks matching only. So that is about the what you call module 4. Then module 5, we have the convolutional code. Okay, convolutional code. If we see here, encoding is there, symmetric and non-symmetric convolutional codes are there. Yes, here it is chapter 11. So there he might have written a little differently. So don't bother much about it. Encoding is there. Then you have structural properties of convolutional code written over here. What is written here? Symmetric and non-symmetric feed forward encoder. Distance properties here written just. Then A, he says catastrophic encoder 11.1, 11.2, 12.1, 13.1. Okay, 11.1, 11.2, 12.1 and 13.1. So Waterbury algorithm is there, but it's not specifically written anywhere. Waterbury, okay, here Waterbury algorithm is there. So might be all this is within the first 11.1 and 11.2 itself, structural properties of convolutional codes, right? Till this it is 11.1 and 11.2, right? We will see how far it is possible. Handwritten notes and all that is a difficult job. Okay, we will see whatever is possible. We'll try to do it, right? So nothing to worry about that. We'll try to see.
Sir, because some of the colleges will provide the handwritten notes, sir.
No, about colleges.
We'll ask that student ನಿಮ್ಮ ಕಾಲೇಜಲ್ಲಿ ಕೊಡಲ್ವಾ handwritten notes ಅಂತೇಳಿ ಅವ್ರು ಕೇಳ್ತಾರೆ sir.
No, okay, that's all right. Let it be there. We will try to see whatever is possible. Okay, if you can collect some material, you can collect it from other places also. Nobody is stopping us. But theory writing down is a difficult job. Numericals, will give more stress to numericals to solve, how to solve and all that. That is more important because understanding component is more important rather than, the theory. Theory, I hope, once you do the B, one can get it very easily. But when it comes to numericals and all, then naturally it will be not so easy, right? So in that sense, if we take, then we can give more stress to the numericals, 12.1 and 13.1. So 12.1 is Waterbury algorithm, 13.1 is the ZJ stack sequential decoding algorithm. Is it that sequential? Yes. Waterbury sequential decoding, log likelihood metric for sequential decoding. So all that might be coming here itself, okay, in the 13.1. Okay, so this is where the syllabus finishes, so to say. And to go back to the material, which little material which I have downloaded might not be totally there. Okay, so what you call here, I have the basic information theory, what you call PPT. PPT, I think PPTX as it is known as. And then I have some part of it here. The books itself, I'll put it in the Google Classroom. The notes also, whatever slides is there, I'll put it. Then the information theory slides is there, this part of it. And then slide 2, there are 2 different sets, each of some around 50 pages. Some of them might not be, some of the slides might just correspond to that, so to say, 5.4, is it 5.4 or whatever, within the, which is not there in the syllabus for us. Okay, so that is, yes, 5.4 lossless also. You can skip that, and then we need to study the rest of the things. So approximately some 50 pages of the slides are there. The book itself will be totally something like, 30 pages from the book, if you take numericals and all. So I think I need to rotate it. So same thing is there from the book. So I think it's better to put the book itself, because continuity sec sometimes we'll face the problem of continuity. So it's better to use the book also in some cases. Okay, so problems are to be approximately 30 pages with 4 pages in the numericals at the fag end from the book. Okay, not much, 26 pages from the book is not much at all. However, you can straight away refer from the text itself. Okay, we'll try to cover the, what you call from the slides, and I'll see whether it is possible to give the notes. Might be if it is available on the net, I will also try to download. If you can collect it from some other source, that also is good enough. Okay, so that's about the unit, the module 1, part 1. These 3 things, basic this thing, and then the info slide theory slides here, info 3 slides 2. Then the introduction we don't have in our syllabus. CC1 is not there. Then you have the algebra, and this is the part 2 of the module 1. Then linear code, it is part 3 of the module 1. Then cyclic code is the module, this is the module, what you call linear is the module 2. This is the cyclic code is the module 3. BCH code is the module 4, and convolutional codes is the module 5. Okay, so part of it might not be there, like from the, if you see the module 4, in addition to BCH code, we have something else also, which somehow I couldn't get any material of slides and all that from anywhere. If I have not searched much, because of that, it might be the case. We'll try to see how we can supplement that and see what can be done about it. Okay, like the 13.1, 12.1, and also the other things might be, the one-step majority code, and such things, 8.1 and 8.4 might not be there. Okay, in the slide set. Okay, we'll see whether it is available at some other place. So if you have any doubts, you can ask. Okay, so we will do whatever is possible from our side. Effort is needed from your side also. Okay, people might be giving and all that, but please remember that we also have our own problems. We have to handle the UG also, and then for you also. We are short of staff, and the situation in all the the colleges there. There is always shortage of staff and people keep coming and going, and hence load will be more. I myself